Hello everybody. So today we'll be going through the last topic of second module, and of course the last topic which comes under friction as well. And this topic is rope and pulley system, or friction involved in rope and pulley system. So before going through the concept of friction which is involved in rope and pulley system, let us try to understand the rope and pulley system in detail. Let us try to understand the concept of rope and pulley system. So in a rope and pulley system, we'll be having two types of pulleys. The first type is driving pulley and the second type is driven pulley. The first type is driving pulley and the second pulley will be the driven pulley. So driving pulley will always be connected to a motor or a shaft. Driving pulley will always be connected to a motor or a shaft, and driven pulley will not be connected. Now, these two pulleys, driving pulley and driven pulley, are connected together, are interconnected with the help of a rope. This is a rope. With the help of a rope. So, since driving pulley and driven pulley are connected with the help of a rope, when driving pulley rotates, for example, in clockwise direction, even the driven pulley rotates in the same direction. This is because you have a rope which connects driving pulley and driven pulley. So when driving pulley rotates in one direction, driven pulley also rotates in the same direction. So rope is in contact with both of these pulleys. And these two pulleys rotates as well. So when rope is in contact with a particular pulley, let us consider pulley as a surface. When rope is in contact with a particular surface, and if surface moves, there is a friction between rope and pulley. So rope is in contact with the pulley moves here, and since it moves, there is a friction between rope and pulley, and will be going through the friction. So first of all, understand there are two types of pulleys, driving pulley and driven pulley. Driving pulley will be connected to a shaft or motor with the help of which the driving pulley rotates, and driven pulley will not be connected to any shaft. Driving pulley and driven pulley are connected. Both the pulleys are interconnected with the help of a rope. So since it is connected with the help of a rope, when driving pulley rotates with the help of motor, even the driven pulley rotates in the same direction. So this is the concept of rope and pulley. So since rope is in contact with the rotating pulley, there is a friction between rope and pulley, so we'll be going through the same friction here. Now, let us assume that the driving pulley rotates in clockwise direction. So when driving pulley rotates in clockwise direction, the lower side of the rope is being pulled. So when driving pulley rotates in clockwise direction, everybody observe, the lower side is being pulled. And upper side is being pushed. This is the case when driving pulley rotates in clockwise direction. As it's been mentioned here in the example. Driving pulley rotates in clockwise direction. So when driving pulley rotates in clockwise direction, the lower side will be pulled and the upper side will be pushed. The side which is pulled is called as tight side, and the side which is being pushed is called as slack side. The side which is being pulled is called as tight side, and the side which is being pushed is called as a slack side. In this case, when the driving pulley rotates in clockwise direction, lower side will always be tight side and the upper side will always be slack side. So similarly, if driving pulley rotates in anti-clockwise direction, in this way. So if you can observe here, the driving pulley rotates in anti-clockwise direction. So upper side is being pulled and the lower side is being pushed. So the side which is being pulled is called as tight side, and the side which is being pushed is called as slack side. So here the driving pulley rotates in anti-clockwise direction. So the upper side becomes tight side and the lower side becomes slack side. As you can observe here, driving pulley is connected to a motor or a shaft, and driven pulley is not connected to a motor. And this particular arrangement will be usually used in power transmission, or to lift heavy objects, as you can see in this particular slide. You can see a box is being lifted upwards with the help of driven pulley. So hope the concept of driving pulley and driven pulley is clear. If the driving pulley rotates in clockwise direction, the lower side will be pulled and the upper side will be pushed. The side which has been pulled is called as tight side, the side which has been pushed is called as slack side. Similarly, if the driving pulley rotates in anti-clockwise direction, the upper side will be pulled and the lower side will be pushed. So the side which has been pulled is called as tight side, and the side which has been pushed is called as slack side. This is how it works. Now, here, when the driving pulley rotates in clockwise direction, the side which is being pulled, that's the lower side, has some tension or force. It carries some tension. And let us name the tension along right side, in this case, when the driving pulley rotates in clockwise direction, as T1. And the tension along slack side be T2. Tension along slack side be T2. Always, tension along tight side will be greater than tension along slack side. Tension along tight side will always be greater than tension along slack side. Here, the lower side is the tight side, and tension along the lower side will be more than that of the tension along the slack side, which is the upper side. This is always constant. Even if the driving pulley rotates in anti-clockwise direction, the upper side will be tight side and the lower side will be slack side. So tension along the tight side will always be greater than tension along the slack side. So always T1 is the tension along the tight side and T2 is the tension along slack side. So T1 will always be greater than T2. T1 will always be greater than T2. Or there is a relationship which connects T1 and T2. That is T1 by T2 is equal to e to the power mu theta. E is the logarithmic constant. Mu is the coefficient of friction. Mu is the coefficient of friction. And theta is the angle of contact. Theta is the angle of contact between rope and pulley. Theta is the angle of contact between rope and pulley. This is the angle of contact. See, rope is in contact with the pulley till this particular point. Let me name this point as A, and here let this point be B. So rope is in contact with the pulley from A to B. So the angle theta is between A and B. This is the angle of contact. Angle of contact. Even here, the rope is in contact with the pulley till this C and this particular point D. So this angle will be theta. Angle of contact will be theta. Angle of contact will be theta. And theta will always be measured in the radians here. Measured in radians. In this particular formula, theta will always be in radians. Theta will always be in radians. If it is given in degrees, you have to convert it back to radians. You have to convert it back to radians. So this is the relationship between T1 and T2. T1 is the tension along tight side, T2 is the tension along slack side. T1 by T2 is equal to e to the power mu theta. Mu is the coefficient of friction, is the logarithmic constant. Theta is the angle of contact between rope and pulley. Angle of contact between rope and pulley. Hope this particular concept is clear. So if the driving pulley rotates in clockwise direction, the lower side becomes tight side. Similarly, if the driving pulley rotates in anti-clockwise direction, the upper side becomes tight side. T1 will always be the tension along the tight side and T2 will always be the tension along slack side. So as you know, this particular system is used in power transmission. There is a formula which is used to calculate the power transmitted. P is equal to T1 minus T2 into V, where V is the velocity of driving pulley in meter per second. Velocity of driving pulley in meter per second. V is the velocity of driving pulley in meter per second. We just have these two formulae to be used to solve the numericals, used to solve the problems. Let us go through the problems one by one. I'll just share and show you the problems. Yes. So this is the first problem. Hope you can see the shared screen. This is the first problem, or problem number 1. Find the ratio of tension in tight side and slack side of a belt with the contact angle 150 degree and coefficient of friction 0.2. So contact angle is theta. Theta is 150 degree. We need it in terms of radians. So convert 150 degrees into radians. 150 into pi by 180, which is 2.61 radians. And mu is 0.2. It's straight away given. So we have to find what? We have to find the ratio of tension in tight side and slack side. T1 by T2 is to be found. T1 by T2 is to be found. We have a direct expression or direct formula to find T1 by T2. So we know that T1 by T2 is equal to e to the power mu theta. Substitute everything. T1 by T2 is equal to e to the power mu is 0.2 into theta. Theta is 2.61 in radians. So finally T1 by T2 is 1.685. 1.685. As simple as that. A direct substitution problem this is. A direct substitution problem. Hope the problem is clear. So this is the first problem. Let us go through the second problem. Let us go through problem number 2. Even this particular problem is simple. Let us go through the second problem. So this is problem number 2. A belt is running over a pulley, making an angle of 160 degrees as angle of contact. Again, 160 degrees theta, it's given in degrees, convert it back to radians. Coefficient of friction is 0.3, mu is given as 0.3. So you have mu, you have theta. So if maximum tension in the belt is 500 newtons, determine the minimum tension and the power transmitted by the belt if the velocity of pulley is 20 meters per second. Now, here the maximum tension is mentioned as 500 newtons. So there are two tensions here, tension along tight side and tension along slack side. T1 will be the tension along tight side always, and T2 will be the tension along slack side always. So T1 will always be greater than T2. So the maximum tension will always be T1. Tension along slack side will always be maximum, and tension along the tight side will always be maximum, and tension along slack side will always be minimum. So T1 will always be maximum and T2 will always be minimum. So here in the question, the maximum tension is mentioned as 500 newtons. So maximum tension will always be T1. Maximum tension will always be T1 and the minimum tension will always be T2. So here you know the value of T1 as 500 newtons, so mu as 0.3, V is 20 newton per second, 20 meter per second, theta is 160 degrees, 160, convert 160 degrees into radians, 160 into pi by 180, which is 2.79 radians. So you have all the data and you have this formula as well. T1 by T2 is equal to e to the power of mu theta. We know the value of T1. T1 is the maximum tension. T2 is the minimum tension. T1 is the tension along tight side, which is always maximum. T2 is the tension along slack side, which is always minimum. So you need the value of T2. So 500 is equal to 500 by T2 is equal to e to the power of mu and theta. You know everything. Find the value of T2, which is 216.50 newtons. So you can find the value of power transmitted straight away using this particular formula. P is equal to T1 minus T2 into V, where V is the velocity of the driving pulley in meter per second. It's given, which is given in the question as 20 meter per second. Substitute it and find the value of P in terms of watts. This is the power transmitted. This will be the second problem. This will be the second. If you know these two formulae, solving problems will be easy here as far as this particular concept is concerned. You have one more problem here. You have one more problem. It's the third problem. Let me share the screen and show you the shared screen. This is problem number 3. A rope is making 1.5 turns around a stationary drum. So what do you understand by this? When a rope makes 1.5 turns, one turn, theta is indirectly given in this. You see, a rope is making 1.5 turns around the stationary drum. So if a rope makes one turn, then theta will be 2 pi in radians. Plus half will be pi. 3 pi radians will be theta. So here theta is indirectly given as 3 pi, and it's straight away, you can straight away measure it in terms of radians. And here in the diagram, the pulley rotates in clockwise direction. And this rotation, this particular force is given as 750 newtons. So if the pulley rotates in clockwise direction, the pulled side will be tight side, and you don't know the tension along tight side, and the pushed side will be slack side, and it is given as 750 newtons. And you're supposed to find the value of T1. The only difficulty here is in finding the value of theta. Theta will be 2 pi plus pi because it makes 1.5 turns. So theta will be 3 pi. T2 is 750 newton. You can identify this just by going through the drawing. Here the pulley rotates in clockwise direction. So the pulled side will be tight side. This is the pulled side and this is the pushed side. Pushed side will be slack side. So 750 newton will be T2 and the other side will be T1. So use the formula and find the value of T1. The only difficulty here is to find the value of theta. Theta is indirectly given as given in the form of this sentence. So rope makes 1.5 rounds. 1.5 rounds. One round will be 360 degrees, 360 plus 180, or 2 pi plus pi, 3 pi radians. So these are the problems available in rope and pulley system. So go through all the problems. This is one of the easiest concepts available in friction. So go through the concepts, and if you have any doubts, you can contact me. Thank you.